So these are some examples related to the moment or the turning effect. And we have a uniform rod. When we say it's a uniform rod, it means the center of the gravity is at the center. It's having a length of 10 meter and a mass of 2 kilogram. Is supported horizontally at position A, 2 meter from the left, and at B, 4 meter from the other end. A mass of a 3 kilogram is placed at P, a 3 kg mass is placed at P, and another mass of a 2 kg at Q. What are the normal reaction forces at the supports A and B? So whenever you see this type of a question, first thing, you should work out all the forces which are acting. As you can see, the mass is 2 kilogram. If the mass is 2 kilograms, so what about the weight? Weight is mass multiplied by gravity. So instead of substituting the value of the gravity, I can also write G. Like I can say 2G. What 2G means, like it's like 2 multiplied by 9.8. So I can also say that the weight is 2G. So weight of the beam is 2G, means 2 multiplied by acceleration due to gravity. Then there's a mass of a 2G is attached on Q, and there's a mass of 3G attached on P. And the two supports are there, A and B, which are experiencing an upward force. So for these type of questions, whenever two supports are there, you have to consider at any one point as a point of rotation or a pivot. And first thing, we'll use the condition how 3G and 2G are there at the end, because it is mentioned in the question, a mass of 3G is placed at P and the mass of 2G means 2 kilogram is placed at Q. That's why it is 3G and 2G is the additional mass which is attached. So first thing, we'll use the condition of equilibrium that there should be no resultant force when object is balanced, or we can say the total upward force must be equals to total downward force. So what is the total upward force? The total upward force is the reaction force of R. The term 2G means, look, weight is mass multiplied by gravity. Mass is 2 kilogram and the gravity is G. If we don't substitute the value of the gravity as 9.8, I can say that the weight is 2G. Here G is not representing grams, it is representing the acceleration due to gravity, or 9.8. So this is another way of representing the weight. So I can say the weight is 4G, 5G, and it's a very common term used in aerodynamics about the motion under the influence of the gravity, or the object move in a circular path, a force of 4G, 3G. That means like times the gravity. So you have to, so this 2G, what it refers to, it means 2 multiplied by 9.8, which is 19.6 Newton. But you can also write that weight is equals to 2G. Not 2 gram, it is actually 2 into 9.8. So R is acting upward, R and S are acting upward, and we can do the same thing. This is just a way to represent. I can do 2 into 9.8 and I'll get 19.6 and I'll solve the question. That will not make any difference to the solution. This is just a way to represent the weight. Another way to represent the weight. Either you write the full magnitude or you write in terms of G. Like I will say, my weight is 70 G. So what does it mean? It will be 70 times the gravity. So R and S are acting upward, and the downward force is what? A 3G is downward, 2G is downward, and 2G is downward. So total downward force is how much? A force of 7G is downward. So it means R plus S is equals to 7G, or 7 into 9.8. Is it clear? Till this point? Any question or doubt till this point? A and B are the pivot that are making an upward force. Will the pivot diagram will be given to us? Yes, usually the diagram is given. the direction of the pivot, usually the diagrams are given for the moment questions. Now it's up to you. Any one of them you can consider as a pivot. So example, if I'm considering A as my point of rotation. So A is a point of rotation. So which direction? The normal reaction force means whenever objects are in contact with the surface will apply an upward force, which is called a normal contact force or a normal reaction force. The force from the surface, like if we are standing on the ground, so the ground will apply a force on us, and we call that as a normal contact force or a normal reaction force. So because the beam is in contact with the pivots, that's why there's a normal contact force upward at position A and at position B. Now I consider A as a pivot. So which direction this will cause a turning effect? Clockwise or anti-clockwise? Which direction of force of 3G cause a turning effect? Anti-clockwise. Which direction this force will cause a turning effect? A force of 2G. Which direction this will cause a turning effect? So this will cause a clockwise. Which direction force S will cause a turning effect? That is also anti-clockwise. Which direction the force Q will cause a turning effect? Clockwise. So it means whenever we solve such question, we always assume that the total anti-clockwise turning effects will be equals to clockwise turning effect. So what are the anti-clockwise turning effect? 3 multiplied by distance from the pivot. So how much is the distance? The perpendicular distance is 2. Plus another anti-clockwise moment, that is S. And how much is the distance from the pivot? So this 3 plus 1 makes 4. So S into 4 equals to the total clockwise turning effect. So this is 2G multiplied by distance from the pivot, that is 3, plus another force of 2G. And what is the distance from the pivot? 3 plus 1 plus 4. So the total is 8. Is it clear, the statements with the equation which is formed here? So 3 multiplied by 2. And this is 3G actually. Like the force of 3G multiplied by 2 plus S into 4 equals to 2G multiplied by 3 and 2G multiplied by 8. So this will be equals to 6G plus 4S is equals to 6G plus 16G. Shouldn't we use the same way in exam like 2G? You can use the G in terms of G. You can also use the weights directly. Like you can write this as in terms of 2G. You can also write as 19.8, 19.6. So we just simplify this. The 4S is equals to 16G. So S is equals to 16G over 4. So S is equals to 4G. So S is equals to 4G. What does it mean? S will be equals to 4 into 9.8. That will give us a value for S, which is 39.24. So value of the S is 39.24 newtons. And what about how to work out the value for R? So R is 7G minus S, and 7G minus S was equals to 4G. So 7G minus 4G, so R is equals to 3G. So mean 3 into 9.8 when we multiply, that will give us 3 multiplied by 9.8. So that is 29.43. So we'll get 29.43 Newton. So the force R is 29.43 Newtons and the 4S is 39.24 Newtons. That's how we work out the total normal contact force or the upward force. Is it clear, this example? Any doubts? So whenever you see the 2 points or 3 points of contact, any one of them of your choice you can take as a pivot. It won't make difference to the final answer. Another example, a ladder question, a ladder of a length 10 meters. So length of this ladder is 10 meter and its weight is 200 Newton. It leans against a smooth wall such that an angle of a 60. A boy of weight 500 Newton stand on the ladder at a distance of 1/4 from the lower end. Like a boy is standing at a distance of 1/4 from the lower end. Calculate the reaction force at the wall and the magnitude of the magnitude and the direction of a resultant force acting at the lower end. So we need a normal contact force of the wall. We need this R. And another thing, we need the total force which is acting at the bottom. So for these ladder questions, what we will do? We will resolve the force into the component. And there's a force F is there. The force F is there, which is making an angle theta. So this is a ladder. And weight is acting downward. A 200 Newton, which is at the center. And another person is there. A boy standing with a weight 500 Newtons. And two forces are acting. One is a force acting at A from the surface. The normal contact force at the surface, that F is there, which is making certain angle theta. And because the ladder is in contact with the wall is also exerting a reaction force. So this is a reaction force of the wall. And we call that as R. And here the angle is given theta, which is 60. This angle is 60. So remember, we resolved whenever weight is acting on the inclined surface, if F is a reaction force, is F a reaction force? So how? Look, yeah, that's a good question. If you see the point of contact of the support of the ladder is having inclined surface, like it is an inclined surface. So which direction the ladder try to push? The weight of the ladder is acting downward. The weight of a ladder is acting downward and the ladder is pushed in this direction, like slide down, but the friction try to oppose that. So the combination of these two, as a result of the combination of these two, the ladder will apply a force, the resultant force in this direction. So that's why there is a reaction force, not exactly perpendicular, but at a certain angle. In case of a ladder, it's not the reaction force is not vertically upward. Why? Because see, when object is on the ground, the weight is acting downward. So weight is a total downward force. So what is the normal contact force here? The normal contact force will be upward and perpendicular to surface. But now in case of a ladder, what happened? This is representing a horizontal surface and this is representing the ladder. What are the forces on the ladder? One is the weight of the ladder, which is acting downward. Another one is the force of a friction which stops the ladder to slide down. So as a result of these two forces, the ladder will not experience a normal contact force or reaction force exactly perpendicular. The normal contact force in case of a ladder will have a certain angle. So ladder tend to slide down, but the friction oppose the motion. So remember always the normal contact force of the ladder specifically, it is not exactly acting perpendicular. It is making certain angle with the vertical axis. Now, as you can see, since the wall is smooth, so the reaction force of the wall is there. That is R. Because why this R? Why not any other? Because in this case, we assume the wall is not having friction. That's why it is perpendicular. If the wall was having a friction, then the normal contact force will also change for the wall. Now, the forces which are acting at the lower end A of the ladder consist of the reaction force and the friction force is there as well. So this will be the resultant force. Like in short, you can say like this is a ladder. There's a friction force. There's a force of the friction. And you take a normal contact force R, which is you take as a perpendicular. So as a result, what will happen? Because of the friction and the normal contact force, there will be a resultant force which is acting at a certain angle. That resultant force we have to determine. So the force which is acting at a lower end of a ladder, it consists of a normal reaction force, as you can see vertically, and the friction force is there, which try to oppose. So there will be a resultant force F is there. So this F is actually the resultant force due to the friction and the normal contact. Now, since we assume that this ladder is in equilibrium, we always assume whenever object is there, we always assume the object is in equilibrium. And we can take the moment or the turning effect about a pivot. Why does the resultant force act in the same direction? So one of the student asked like, why does the resultant force act is same as the direction of inclination? Because see, if there's an upward normal contact force, there's a friction and this force is there. So these two forces combine and the combination of these forces give a resultant force. Because this R, so if it was only two forces were acting, then the resultant force will be same as the inclination of the ladder. But because the ladder experienced a normal contact force or reaction force from the wall, so the resultant force will slightly change. The inclination of the resultant force will slightly change. $500 Newton is a boy which is standing on the ladder. His weight is 500 Newton. Now we are considering a moment, moment about A. The turning effect about A. Or A is a point of rotation. So we can write R like which direction, if you try to identify these turning effects, R will cause which direction turning effect to the ladder, clockwise or anti-clockwise? Which direction R will try to cause a turning effect? So R is causing an anti-clockwise turning effect. Good. Which direction 500 will try to cause a turning effect? Clockwise. And which direction 200 will try to cause a turning effect? Anti-clockwise. Good. So then we need the distance. How to work out the distance? The force is R, but what about the distance? Because we always take the perpendicular distance. Why we did not take F? Because F is acting on the pivot. When the force act on the pivot, the force will not cause any turning effect. 200 Newton and 500 Newton are causing a clockwise, and R is causing an anti-clockwise turning effect. 200 and 500 clockwise, and R is anti-clockwise. Now, we have the force R, but we need this perpendicular distance. So how to know the perpendicular distance or a 90-degree distance? Look, the length of the ladder is 10. This ladder is 10 meter in length. And this was R. And here it was making an angle 60, as I mentioned. So this distance will have two components, horizontal and vertical. So this will be equals to, I always need the vertical component. So what is the vertical component? Like a 90-degree component. So this will be equals to 10 sine 60 degrees. So I can write R into 10 sine 60 degree. Is it clear till this point, the first one? The length of the ladder multiplied by, yeah, I will repeat. Look. See, this one, we have a ladder which is 10 meter long. Here is the point of rotation. We took pivot. There's a force R is there. So if I increase this R, so mean this is R. I need the perpendicular distance. I need this distance. And this distance, these two distances will be same. Like this vertical distance will be same as this distance. Here it is making an angle 60 degree. So we will have the two components, like this is 10 and angle theta is there. So I can use a trigonometric ratio, like I have the base is there, I have the perpendicular, and this is a hypotenuse. So base, perpendicular, and hypotenuse. So I can use a sine theta. Sine theta is perpendicular divided by hypotenuse. So sine theta, the perpendicular, we don't know, and the hypotenuse is 10. So 10 will be multiplied. So what is the perpendicular? The perpendicular is 10 sine 60. So if this distance is 10 sine 60, how much is this distance? That will also be 10 sine 60. Because to get the turning effect, we need the force and we need the perpendicular distance. So what is the perpendicular distance here? So the perpendicular distance will be 10 sine 60. So I will write R multiplied by 10 sine 60. Is it clear to everyone? This perpendicular distance and the force that is causing an anti-clockwise turning effect. Now I need the clockwise turning effect. The force of a 500 Newton is causing a clockwise turning effect. And what is the distance? How much this length is there? Because they mentioned it is 1/4 way. So means that is equals to 0.25. Because if the total length is 10, this distance will be 0.25. So a force of a 500 Newton, a weight of a boy is 500 Newton at a distance of 0.25 meters. And that is also making angle 60 degree. I need the perpendicular component. I need the component of the force, which is distance, which is perpendicular to force. So what will be this component? This will be equals to 2.5 because it is 1/4. So this is 2.5. So this will be equals to 2.5 cosine 60 degree. And this will be equals to 2.5 sine 60. So when this was an anti-clockwise turning effect, but when I'm finding the clockwise turning effect, how to find the clockwise turning effect? But we consider perpendicular length. we always consider the perpendicular length. So we need this length, the force and the perpendicular distance. So what is the perpendicular distance? In this case, the force is equal to 500. The force is equal to 500 and the perpendicular distance will be equal to 2.5 cosine 60. Is it clear? Anyone having a doubt or a question till this point? The ladder questions are all solved in the same manner. That's why I'm taking more time to explain the idea. Like it can be done within 5 minutes, but every time a question is having a symmetry, so you solve in the same manner. Then we have another turning effect. How much is this distance? It's a uniform, so this will be 5 meters. So what is the perpendicular distance? The weight of a ladder is 200 Newton and it is acting at a distance of 5 meters. So how much is this distance? This angle 60 is there. So it is making an angle. So this will be equals to 5 cosine 60. So this will be equals to 200 into 5 cosine 60 degree. So 500 into 2.5 cosine 60 and 200 into 5 cosine 60. That is causing a clockwise turning effect and this is causing an anti-clockwise turning effect. And we will assume the clockwise and anti-clockwise turning effects are equal. So R into 10 sine 60 will be equals to 500 into 2.5 cosine 60 plus 200 into 5 cosine 60. And we'll solve for a value of R. So just divide by 10 sine 60, we'll get the value for R. R will be about 130 newtons. That is this value of R. Is it clear? How we work out the normal contact force? Anyone having a doubt or a question till this point? Yeah, we will calculate F as well. First thing we calculated R. That's the first thing. Now, so we are done with R. We calculated R. R is 130 Newton. Now we want to solve for F. How F can be done? How we can solve F? F will have two components. F will have two components. One is with an angle, another one is against the angle. So with an angle, this will be F cosine theta, and opposite to the angle will be F sine theta. So we can write now the equation that F cosine theta, which is acting upward, minus 500 minus 200 will be equals to 0. That is one of the equation. Or we can say F cosine theta is equals to 700. And same way, this is when we consider the vertical forces. Then we'll consider the horizontal forces which are acting. The F sine theta is acting towards the right and R is acting towards left. So we can say F sine theta minus R. F sine theta minus R is equals to 0 or R is 130. So I can say that F sine theta is equals to 130. So what we did, look, yeah, I will repeat. See what we did, the force F was there, okay? The force F was having the two components. As it was making angle theta with a vertical. So this force was having two components. One is with an angle, another one is opposite to the angle. So this one which is with an angle, that is F cosine theta, and opposite to the angle is F sine theta. So what we did, because it is in equilibrium, the total upward forces must be equal to total downward forces, and total forces which are acting right must be equal to total forces acting left. So total upward force F cos theta is acting upward, or you can say this components, you can also say the component, like you can say y, or you can also say x. If you are confused with cosine and sine, you can say y and x. It does not make difference. So y is acting upward, and 500 is acting downward, and 200 is acting downward. So what is the value of the y? The value of the y is 700 that we worked out. Means this is equal to 700 Newton. And the total forces which are acting on the right must be equals to towards the left. So force which is acting towards the right is F sine, which I called x. And total force which is acting towards the left is a normal contact force, which is 130. So the value of the x is 130. So I can say F sine theta is equals to 130. Now we have the components. We have like 700 Newton this, and we have 130 Newton. So if we want the resultant, how to work out the resultant? You can use a Pythagoras theorem. So according to Pythagoras, it will be under root 700 square plus 130 square. So the value of the F will be equals to 712 Newtons. That's how we work out the value for F. And how to get the angle? The same way, you have the base. Like I have a right angle triangle and I need this angle. I have the base and I have the perpendicular. So I can use a trigonometric ratio tangent theta, which is perpendicular divided by base. So theta will be tan inverse perpendicular over base. So 100 divided by 700, 130 divided by 700. So you will get the angle from the vertical of the resultant force will be 10.3 degrees. 10.52, okay. 10.52 degrees. So these ladder questions are common type of questions in exam. So I'll repeat how it can be done. So first what you do, because in the question we need the resultant force acting on the ladder. Sometimes they only ask for a normal contact force, like this part might not be there. Some of the question, this part might not be there. So in that case, how to solve this? You take a pivot, always take a base as a pivot, okay? Make a rule that make base as a pivot. So this will always, the weight will cause a clockwise rotation, and a normal contact force from the wall will cause an anti-clockwise. And then, so R into this distance from the pivot. And these distances will change according to the distance of an object. Any doubt in this? The ladder question? Is it clear? Then we have another question, like example, figure shows a person bending over his back horizontal to lift a load of a 60 Newton. The spine is considered as a pivot, like you can see it's a pivot. The weight of the upper part of the body is 250 Newton. So weight is acting downward. The tension in his back muscles, the horizontal compression force H on the spine, and the vertical force on the pivot. The diagram is given to you, like the diagram is a part already in this. So how to done this? We'll consider again it is in equilibrium. So a 60 Newton will cause an anti-clockwise rotation. This gravity, the weight, the downward force will also cause an anti-clockwise rotation, and this tension will cause a clockwise rotation. But this tension will have the component. What are the component of the tension? One is with an angle or opposite to the angle. So what will be the component we will take? We'll take this vertical component, and that is equals to T sine 12 degrees. V is a compression force on the muscle, like on the bone, on the joint. It's written T is a tension, horizontal compression force H on the spine. Like how much force is there on the spine? That is a horizontal force. And because the spine will experience two forces, the horizontal and the vertical forces, to balance. That's why, like example, if you try to lift a heavy load, where you will feel the pain, you don't feel the pain in your hand. Where you will feel the pain, you'll feel the pain and the back, the spine. The main reason is that because all the resultant force is acting on the spine. That's why, like example, when a weight lifting is done, there is a technique of lifting a weight, which makes it easy and reduce the compression force, the horizontal and the vertical forces on the spine. So how it can be done? First, if we need the tension in the back muscle, so this will cause a clockwise, these two will cause a anti-clockwise turning effect. This will cause a clockwise turning effect. So I will write the expression. So it will be 60 into the total length, example L, plus the weight, which is 250, multiplied by, it is acting at the center, so L by 2 equals to anti-clockwise. So it will be T sine 12, the force, multiplied by distance. It is acting at a distance of L by 2L by 3. So we'll write 2L by 3. L is common, so L will cancel out. It's common. And then we simplify for T. So T will be about, I'm not exactly sure of answer, but it is normally in the range of 1300. So example, we took 1300 or 1330 newtons. But this is not exact. It might be different. I don't remember the answer. But it will be in this range. Then we need the horizontal force. So how to work out the horizontal force? Look, we used how to work out the horizontal force. The total force acting towards the right must be equal to total force acting toward the left. So this T cosine 12 is acting towards right. So T's cosine 12 is acting towards right, and the horizontal force is toward left. So H is equals to T cosine 12 degrees. And to work out the vertical forces, the upward force must be equal to the downward force. The upward force must be equal to the downward force. So what is the upward force? The upward force is V. And what about the downward force? The downward force is, and there's also another upward force. One is V, another one is T sine 12. Because T sine 12 is acting upward and V is also acting upward. That will be equal to downward force 60 plus 250. And then we'll solve for V. Is it clear how we work out H and V? Any doubt in this? V is not the tension, V is the force, because when object is in equilibrium, the total upward force equals to downward force. So T sine 12 is acting upward, weight is acting down, the force is also acting down. So V is a force on the pivot, which is upward force, so that it will be balanced. And there is a horizontal component, so there will be a horizontal force to balance that. Otherwise, what will happen? It will damage the spine. The T sine 12, it will damage the spine if it is more than the force which is produced by the pivot. Any question or doubt related to the session today? We completed the moment topic. I plan to do the density as well, density and upthrust, but inshallah tomorrow we'll do that. We'll start with explanation because I want to cover these topics this week. So inshallah we'll start tomorrow with explanation and then we'll do the weekly discussion, the homework discussion. Any question or doubt related?